Hello everyone, I am Suchita Mori. In this video, we are going to discuss numerical method solution of system of simultaneous linear equation, and name of the method is Gauss-Seidel method. There are mainly three different methods to solve simultaneous linear equations. Now, Gauss elimination method, first one, second Crowd's method, third is Gauss-Seidel method. Now in this video we are going to discuss Gauss-Seidel method. Now method for solving this Gauss-Seidel method is we consider the given equations 1, 2, 3. Then the method of iteration is applicable only for the system. This is the most important point here. The- This mod of a1, this value is greater or equal to mod of b1 plus c1. That means this is the most important point. Now second for b2, this value is greater or equal to a2 plus c2. That means remaining addition of remaining two elements. Mod of c3, again here this value which is greater or equal to sum of the remaining two elements, coefficient of this x and y, that means a3 plus mod of b3. Now if this condition is not satisfied, then we cannot apply this Gauss-Seidel method. This is the most important point. That means if the equations are given, first step we have to rearrange the equation according to this condition. Now here, if we observe A1 means first diagonal element, B2 is second diagonal element, and C3 is third diagonal element. That means this matrix we get we reduce these equations as a diagonal matrix. Okay. Now then from equation 1 we have to find out value of x. From y we have to find out y value of y, and z. From third equation we have to find out value of z. Then we start the iterations. We start with the initial approximation y not equal to 0 and z not equal to 0. We have to substitute this value in equation 4. Then find out the value of x which is denoted by x1, that means d1 by a1 because y and z values are 0. Now here x equal to x1, that means this value, z not equal to 0, we substitute this in equation 5 and find out the value of y1. Similarly, put x equal to x1, y equal to y1 in equation 6 and find out the value of z1. That means after first iteration we get the value of x1, y1, z1. Now we use this for second iteration as a initial values. Therefore, for second iteration x2, y2, z2, we get x1, y1, z1 as initial values. Continue this process till the values of x, y, z are found to be desired degree of accuracy. Now we discuss problem on this. Here, apply Gauss-Seidel method to solve the equations. Now here equations we have to rearrange the equation. Now for this rearranging the equation here, these we consider second B equation as first equation because this value coefficient of x is greater, therefore we write down this as first equation. Then secondly in C equation here second value is greater than sum of the remaining two coefficient of x and z. Therefore, we consider this C equation as second equation and A equation as third equation. Now, from this first equation, we shifted this y and z to z term on right hand side and find out the value of x. From second equation, we find out value of y by shifting x and z value on other side, and here then we find out the only value of y by dividing by 20. Similarly, we find out from third equation value of z. Now we start the iterations now. By considering y not equal to 0 and z not equal to 0, substitute this value in equation 1. Therefore, we get x equal to x1, this value is 0.85. Now here all values we have to find out up to 4 decimal place. Now x1 equal to this 0.85 and z not equal to 0. Substitute in this in equation 2 and find out the value of y1. This is the value of y1. Now for third equation x1 and y1 we substitute and then find out value of z. In this way we get x1, y1, z1 value after first iteration. Now we apply these x1, y1, z1 as the initial values for second iteration for finding x2, y2, z2. Therefore, here now we substitute y1 and z1 in equation 1 and find out x2 value. Similarly, x2 and z1 substitute in equation 2, find out y2 value, and x2, y2 in equation 3 and find out the z2 value. In this way, we find out x2, y2, z2 and we use these values for the third iteration as initial values. Now we continue this process till we get the values of x, y, z to desired accuracy. Now continue this process and find out the values of x3, y3 and z3. Now here this first value x3 value is 0.9999. This is approximately equal to 1. Now here y3 equal to minus 1. Some of the students get the value minus 0.9998. This also is approximately equal to minus 1. Now if we substitute these values, then we get here x3 means this value. Then here x3 equal to 1, y3 equal to minus 1, then we get z3 equal to 1. In this way, these are the values x, y, z in desired accuracy. Therefore, we write down the last values in the table. Iterations x, y, z values. After first iteration, these are the x1, y1, z1 values. Then x2, y2, z2 and x3, y3, z3. Now this value is approximately equal to 1. Therefore, x equal to 1, y equal to minus 1, z equal to 1, which are the required values of x, y, z by using Gauss-Seidel method. In this way, we solve the problems of Gauss-Seidel method for solving simultaneous linear equations.